Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. To both of my panels, Dr. Muhammad Nasir Muhammad Tahir and T.S. Rusnawati Buhari. I will be presenting my master project 2, and the title is Physical Properties of Coagulum Styrene-Butadiene Rubber and Nitrile-Butadiene Rubber Modified Asphalt. I am Farraheen Zain binti Jeffrey Zain, HF190074, and my supervisor is Dr. Nurul Hidayah binti Muhammad Kamaruddin. This is the outline for my presentation. First one is background study, second literature review, third research methodology, result analysis, and conclusion and recommendations. Asphalt binder is one of the main components in pavement materials. Good modifier addition to modify the asphalt binder can improve failure. Polymer modified asphalt has been widely used due to their benefits and able to improve the performance properties of asphalt mixture, including natural rubber latex. However, natural rubber consists of high water content and susceptible to bacterial attack. This issue can lead to low homogeneity. Previous studies said that a few cruds that can produce good asphalts and only a limited number of actions that can be taken to control the refining process to make improved asphalt. Thus, this study were conducted to investigate the effect of coagulum rubber, SBR and MBR, on the physical properties of asphalt binder. It is also to determine the appropriate content of asphalt binder modified with SBR and MBR. In this study, 60-70 penetration grade asphalt were used as base binder. Modified binder samples then were prepared with different percentage of synthetic coagulum rubber, SBR and MBR. This study was focused on the physical properties which were penetration, softening point, viscosity and ductility. Laboratory studies were carried out at Advanced Highway Laboratory UTHM by following the ASTM standard. The basic properties of asphalt binder of penetration 60-70 were shown in the table, and this value shows the test result for asphalt binder with 0% concentrations. This binder is fulfilled the requirement. Most SBR and NBR modifiers are found in latex form. There is another product called as coagulum. Coagulum is a product of the sieving process of latex. So based on the reviews, coagulum usage in asphalt binder is still not very much explored. This is the two synthetic coagulum rubber that used in this study. The SBR coagulum is in fine lumps, while the MBR coagulum is in solid pieces. This is the research methodology for these studies. In these studies, the asphalt binder penetration 60-70 were blended with SBR and NBR with concentration 3% and 5% by weight of asphalt binder. The coagulum modified asphalt binder were prepared using high shear asphalt binder mixer. The base binder, penetration 60-70, about 500 gram, were heated in the oven at 170 degrees Celsius until fluid state. Before adding the additive, the asphalt binder was stirred for 5 minutes to obtain uniform temperature distribution, and the coagulum then were added progressively. The speed of mixer was maintained at 2000 RPM for 120 minutes, around 2 hours, at 170 degrees Celsius to allow for a good homogenization. The coagulum modified asphalt binder then were further analyzed on the physical properties with penetration test, softening point test, viscosity test, and ductility test. All these tests were determined for unaged condition. This is the result and analysis part. which is the first figure, shows the penetration value. The penetration value of SBR Coagulum modified binder shows different trend compared to NBR Coagulum modified binder. The penetration value for the sample with 3% and 5% SBR were 64.3 dmm and 63.4 dmm as the amount of SBR increased. The penetration value were slightly decreased. For NBR Coagulum modified asphalt binder shows the penetration value with 3% NBR in asphalt binder is 59.8 dmm, while 60.7 dmm with 5% NBR added. The penetration value increased by increasing the concentration of NBR. The second figure is the softening point result. The softening point result will increase in addition of SBR and NBR in asphalt binder. The softening point values of base binder were increased by 14.3% and 21.1% respectively as the addition of SBR with 3% and 5%. The softening point reached 60.9 degrees Celsius with 5% SBR added. As for NBR, modified asphalt binder with 3% NBR, the softening value were increased 6.2% than the base binder with 0% NBR added. The third figure is for the penetration index, PI. The PI value were defined to measure the susceptibility of asphalt binder. Overall trend shows that the addition of SBR and NBR coagulum increases the PI for unaged binder. The result indicates that by adding 3% of SBR and NBR increases the PI from negative 0.5 to 1.2 and 1.8 respectively compared to base binder. Therefore, the temperature susceptibility of asphalt binder will enhance by the increasing of PI value. This is the result and analysis for viscosity values coagulum modified asphalt binder. The viscosity values were recorded at temperature of 135 degrees Celsius and 170 degrees Celsius. The viscosity values for both SBR and NBR coagulum modified asphalt binder were decreased as the temperature were increased from 135 degrees Celsius to 170 degrees Celsius. Asphalt binder modified with SBR 3% has the higher viscosity value at 1536 pascalseconds and 345 pascalseconds for both 135 degrees Celsius and 170 degrees Celsius, while with the 3% concentration of NBR, the higher viscosity value with 1395 pascalseconds and 273 pascalseconds for both 135 degrees Celsius and 170 degrees Celsius. The result shows a general trend that with 3% concentration of SBR and NBR added result in rise of binder viscosity compared to base binder. This figure shows the ductility values for modified asphalt binder. Asphalt binder with 0% concentration elongated more than 150 cm. The ductility of coagulum modified asphalt binder was decreased with the increasing of SBR and NBR concentrations. This indicates that with the increasing percentage of SBR and NBR in asphalt binder, the stiffness in modified asphalt has increased. From figure here, the base binder with 3% concentration of SBR and NBR shows the decreasing from more than 150 cm to 37.8 cm and 37 cm. Next, this table shows the summary result for all the sample tested. The optimum modified binder for both SBR and NBR coagulum asphalt is 3%. Based on the results obtained, the penetration, softening point, and viscosity for 3% and 5% concentrations of both SBR and NBR coagulum modified binder show slightly different from asphalt binder with zero concentrations. Meanwhile, the results from ductility shows a huge difference from control binder. Thus, due to the ductility, the appropriate amount for both coagulum modifier to use in asphalt binder is 3%. As for the penetration value of coagulum modified binder were increasing with the increasing of percentage of SBR, while with the increasing percentage of NBR into asphalt binder, the penetration value is increasing. The softening value of coagulum modified asphalt binder were increasing as the concentration of both coagulum were increasing. So the conclusion is that based on the results obtained, the appropriate content of SBR and NBR coagulum modified asphalt was suggested as 3%, and the SBR and NBR have improved in stiffness, resistance to reformation, and temperature susceptibility. Both coagulum modifier can be used as modifier in asphalt binder. To produce good quality of asphalt binder, there were many studies use polymer as alternative. However, the usage of coagulum rubber as modifier is still limited. Therefore, the following recommendations are suggested. First, the detailed evaluation of SBR and NBR coagulum rubber properties should be conducted thoroughly. Second, the study was focused on physical properties of coagulum rubber modified asphalt. Thus, it should be further investigated in terms of short-term and long-term aging. Third, it is recommended to further the studies by investigating the effect of different SBR and NBR concentration in asphalt binder with different range of temperature. Lastly, the ductility was found decreased with the increasing of SBR and NBR coagulum. It is suggested to conduct for rheological testing in further to investigate the performance of this modified binder. So that's all from me for my master project, Physical Properties of Coagulum, Styrene-Butadiene Rubber and Nitrile-Butadiene Rubber Modified Asphalt presentation. Thank you.